Hello all, welcome back to operating system course. So in the last video we had seen about protection and security in the operating system. Then we had seen distributed systems and some special purpose systems. So today we'll get started with the computing environments. So here we will give a brief overview on how your computer system organization and your operating system components are used in variety of computing environments. So here we will study about traditional computing, client server computing, peer-to-peer computing and web-based computing. So the first one here is traditional computing. As the name suggests, it is using physical data centers for storing digital assets and running complete networking system for daily operations. So in this traditional computing, access to your data or software or storage by the users is limited to a device or official network they are connected with. Okay, so in this computing, users can have access to data only on the system on which the data is stored. So consider the typical office environment. So just a few years ago, this environment it consisted of PCs connected to a network with servers providing file and printer services. So remote access was awkward, okay, and the portability was achieved by the use of laptop computers. The terminals attached to the mainframes were prevalent at many companies as well, with even fewer remote access and portability options. The current trend is towards providing more ways to access these computing environments. Web technologies are stretching the boundaries of traditional computing. Companies now they establish portals which provide web accessibility to their internal servers. Let's consider a situation at home. So at home, most users had a single computer with a slow modem connection to the office, the internet, or both. So today, the network connection speeds once available only at great cost that are relatively inexpensive, giving some home users more access to the data. So these fast data connections are allowing home computers to serve up web pages and to run networks that include printers, client PCs, and servers. So some of these even have firewalls to protect their networks from security breaches. So today the traditional time sharing systems are uncommon. The same scheduling technique is still used. It is still in use on workstations and servers, but frequently the processes are all owned by the same user. Okay. Next we'll move on to the client server computing. So as the PCs, your computers have become faster, more powerful and cheaper. So the designers have shifted away from the centralized system architecture. So here the terminals are connected to the centralized systems are now being supplanted by PCs. The user interface functionality once handled directly by your centralized systems is now being increasingly handled by your PCs. So as a result, many of today's systems they act as server system which satisfy the requests that are generated by the client systems. So this form of specialized distributed system we call it as client server system. Okay. So here is the general structure for your client server system. So one system access servers and over the network clients are connected to it. Okay. Now the server systems, this one, they can be broadly classified into two types. That is one compute servers and the next one is file servers. Okay. So in compute server system, it provides an interface to which a client can this client can send a request to perform some action such as to read the data. Okay, so in response, your server the server what it does is like it executes the action and sends back the result to the client. So a server running a database that responds to a client request for data is an example for this one. Okay, the next one is file server system. So it provides a file system interface where the clients can create, update, delete, modify the files. So example of such system is a web server that delivers files to the clients running web browsers. So this is about your client server computing. The next one is peer-to-peer computing. So this is another structure of distributed system. So in this model, your clients and servers, they are not distinguished. I mean, they are not differentiated from one another. So instead, they act as a peers, or all the nodes within the system are considered as peers or at the same level. Okay, they either act as a client or a server depending on whether it is requesting something or it is providing a service. So if it is requesting something, then it is a client, and it is providing a service, that means it is a server. So in a client server system, the server is the bottleneck, that is the problem. Why? Because if the server fails, then you cannot fetch the data or do anything with the files, right? So but in peer-to-peer system, what will happen? The services can be provided by other nodes that are distributed throughout the network. So if a PC or if a node, if it wants to participate in a peer-to-peer system, what it has to do first is like it has to join the network of peers. Okay, so once the node joins the network, now it can begin providing the service, or I mean, it can, once it joins the network, it can either act as a client or server. Okay, so what are the services that are available? So it can be handled in one of the two ways. The first one is when a node it joins a network, it has to register itself or its services with a centralized lookup service on the network. So when a system it joins the network, it has to tell the network that it can do these many tasks. Now what are the tasks that would be handled by the node are maintained in a centralized lookup service. Okay, so any node, if it wants that a specific service first, it contacts this particular lookup. So to determine from this lookup, it can determine which node it provides the service. So the remainder of the communication takes place between the client and your service provider. So now centralized lookup service, it is okay. For example, consider your journal. Okay, that is your first page would be table of contents. So what do you do in that table of contents? What do you write? So you write the program name and then you write the page number. Okay, so say suppose on that particular page you have written, or you have say suppose 20 entries in that table of contents, like 20 programs you have, program names or the problem statement you have written, and the corresponding page number you have written on that content sheet, right? So say suppose whenever, okay, you open that journal and say suppose you want to you know um, open the fifth program which is in your journal. So what do you do? Either there are two ways. One way is like just go on turning all the pages till you reach your fifth program, or else the better way is to search for the table of contents, search for the page number and directly go to that particular page number, right? So your centralized lookup service is something similar to your table of contents. So when a node it joins the network, first what it does, it registers its services, that or what are the services it is providing, and those services will be kept, or it is described in centralized lookup service on the network. Say suppose there is a node 2 which is a client. Okay, so it is requesting, or it is desiring to perform the task which is uh, only provided by that particular node which has joined the network just now. So your client now, what it has to do is like first it has to check the lookup service. From the lookup service it will check which node is providing that service, and then what it does is like it directly contacts the node which is providing the service. Instead of going and asking everyone whether you provide this service or not, what you can do with the lookup service is like you can directly talk to that particular node which is giving you a specific service. Okay, now the second way is like a peer or node acting as a client, it must first discover what node provides a desired service by broadcasting a request for the service to all other nodes in the network. Okay, The node providing that particular request responds to the peer making a request. To support this approach, a discovery protocol must be provided that allows peers to discover services provided by other peers in the network. So this means, let's take an example to understand this one. Okay, say suppose I'm taking your class. Okay, so offline class basically. Okay, so and while teaching, say I would broadcast a message saying, or I'll ask all of you who are in the class that whether you have a pencil, and suppose among you only one has the pencil. Okay, now that particular person who has the pencil, they'll respond to me, he'll respond to me, or she'll respond to me. Then what I'll do, I'll directly go to that person, I take the pencil and do my work. Now this is same as the second point, that is a peer or a node which is acting as a client. First what it does is like it has to understand which node or which other nodes or the peers they are providing what service. So to understand this one, which system is providing which service, so first it will broadcast a message, or it would ask all the nodes what service you are providing. So once it gets the response from all of them, now it is the peer which has made that broadcast request, right? So it will check whatever it needs, it will directly talk to that particular specific node wherein it does the work. Okay, so this is how you can um, or the peers can talk to each other in peer-to-peer computing. Okay, the next one is web-based computing. Web computing, it has increased the emphasis on the networking. Devices that were not previously networked now include wired or wireless access. Devices that were networked now, they have now faster connectivity provided by either improved networking technology, optimized networking implementation code, or both of them. So the implementation of the web-based computing has given rise to a new category of devices such as load balancers. So that will distribute the network connections among a pool of similar servers. So your systems, operating systems like Windows 95, which acted as web clients, have evolved into Linux and Windows XP, which can act as web servers as well as web clients. Okay, so generally the web has increased the complexity of the devices because their users now require them to be web enabled. Next, we will talk about open source operating systems. So open source operating systems are those systems wherein the source code is made available. Okay, rather than your compiled binary code, the actual source code is made available. So Linux is the famous open source operating system, and your Windows is the closed source operating system. So what is the use if you make the source code available to all? What are the benefits of it? So first we'll see who will work on it. Okay, as because it is made free, who will work on it? So it is a community of interested programmer or the people who contribute to the code. Initial code would be there, then the community of people or your group of people, what they do, they take the code, they analyze the code, and if there are any bugs in it, they fix it, and they provide uh, you know they support changes or suggest changes to this operating system. As because many people are using or analyzing the code, it is more secure than your closed source code. Next we'll talk about the bugs or errors in the open source operating system. So will it have any errors? Yes, it will have errors or the bugs, but the fixing or the finding of the defects or the bugs and fixing is much more faster. The companies that earn revenue from selling their product, they tend to be hesitant to operate, to give their code or to make their code open source. But there are companies that are doing just that and showing the commercial companies that they benefit rather than suffering, they are benefiting from their open source code. Again, the revenue, how they are generating the revenue if they make so operating system as open source. So they can earn the revenue by selling of the hardware on which your software runs, and through their support contracts. So this is all about open source operating systems, and this completes your first chapter. Okay, so go through Canvas and go through these videos again and again, and check if you don't understand something. Please do respond by sending me an email or commenting on the video. Okay, let's end the session. Thank you.